Alright guys, so what I want to do in this video is to give you a reminder of the factorial. Okay? Now hopefully you remember having seen the factorial before, which was something like this. Now what that means is n times n minus 1 times n minus 2 all the way down to times 1. So for example, if this was 6 factorial, that would be 6 times 5 times 4 times 3 times 2 times 1, which note that that could be written as 6 times 5 times 4 factorial. Or, 6 times 5 times 4 times 3 factorial. Or 6 times 5 factorial. So just trying to get you comfortable with different ways of writing that. Now, where is this useful? Well, in combinations, when you do NCR, which is also sometimes seen this way, NCR, that is the same thing as N over R. Usually in class this is the way I've written it, but that is equal to N factorial over R factorial times N minus R factorial. Okay? Now remember, this refers to the element, this is the row of Pascal's triangle, whereas this is the element, starting at row 0 and element 0. Alright, so something like this would be like, say we had 5, 3. Okay, so that would be something where we had something, let's say it was x plus y to the 5th power, and I wanted the term where it was y to the 3rd, right? Because remember, we can write this as 5, 0 times x to the 5th plus 5, 1 times x to the 4th, y to the 1st, plus 5, 2, and so on and so forth. Right, so this hopefully you're familiar with. This should be just kind of a reminder of what's going on here. So this 3, remember, should match up with the exponent of that second term. They should add up to give you 5. So 5, 3 would be that term right there, that coefficient. Now, that doesn't necessarily have to be the whole coefficient of this term, because if x or y had numbers in front of them, then those numbers would also add into the overall coefficient of the term. But this is the binomial coefficient, which is just the 5, 3. So the way that we could do that is by using factorial. You could draw the Pascal's triangle for this, but one way to do it would be to go n, which is 5 factorial. Now this equation is in your equation booklet. And so then we've got r factorial and then n minus r factorial. Okay, now the way we would go about working this, we'd say, okay, well that's 5 factorial, and that's going to be divided by 3 factorial times 5 minus 3, which is 2 factorial. And then how I would do this is I would say, okay, well that's 5 times 4 times, and then I'm not going to write out the 3, 2, 1. I'm going to write down whichever of these two is the larger factorial. Okay, if 3 is larger, then I'm going to stop at 3. If this is the large one, then I'll stop at that one. Okay, but I want to cross out the largest factorial possible, because what's going to happen is that the 3 factorials here are going to be able to cancel out, which means that now I'm just left with 5 times 4 over 2 factorial. And 2 factorial is just 2 times 1, which is 2. So that would be 5 times 4 is just 20 over 2. So it would be 10. Now if you were to do Pascal's triangle, you could find that. If you were to pull up your calculator and do 5 NCR3, then you would get 10 as well. Alright, so that's just a use of the factorial. Now, the reason why I'm bringing this up is because I want you to be able to deal with this kind of problem if it's a binomial probability or something like that. So let me give you an example. So in the expansion 2x plus 1 to the n power, the coefficient of x cubed is 80. Find n. Now, if you're like me, then what you would probably do looking at this, you say, oh, well, I can just write out the expansion. And so what you're going to do is you're going to say, okay, well, the coefficient, binomial coefficient will be n 0, because that should be the power, right? And then it'll be 2x to the n power and 1 to the 0 power. And then I'm going to go plus n1, which will be 2x to the n minus 1, and then times 1 to the first power. And I can follow that pattern. Each time this needs to decrease by 1 more, this one needs to increase by 1. But you'll notice that that's not going to actually help me get x to the third. That's going to be a problem because I'm always going to have an n here, and I don't know what n is. So I can't really find it. So what I'm going to do is I'm actually going to jump to the end, right, to where I have n. Now n will be multiplied by 1 to the n power. And then before that, it'll be n over n minus 1, which will be 2x to the first power, and then 1 to the n minus 1, right? And so I'm going to be subtracting 1 from that and adding 1 to the x, because the 2x was to the 0 power the first time. So I can keep going, right? So n over n minus 2 of 2x squared, 1 to the n minus 2. Oops, sorry, that should not be inside there. That should be outside. Okay, and now I'm to the x squared. So I just need x to the third term. So you can tell that the one I'm looking for is n minus 3 of 2x to the third times 1 to the n minus 3. Now, some of you may be familiar enough with the formula booklet that you may be able to say, well, you know, I could have just come up with this in the beginning because I know that an individual term is nr times a to the n minus r times b to the r, right? And r is the same thing as that one right there. See, these two should always be the same. That's what we were just talking about in the previous problem. So if you're comfortable with this, you may be able to jump straight to this step to know that n minus r needs to be 3. And if n minus r is 3, then r, so if I go n minus r equals 3, then I'm going to subtract the n. And so negative r equals 3 minus n. So therefore r equals n minus 3 multiplied by negative 1. And it becomes n minus 3. So you should be able to get this right here, either by writing it out or by using the formula and figuring out what r is. Okay? Now, at this point, you could do the factorial. It's going to be valuable to you to be able to recognize that n over n minus 3 is the same thing as n3. So remember Pascal's triangle. Let's go write Pascal's triangle. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10. You should be familiar with this enough that this is not weird to you. Notice, however, that opposite sides are always the same. It's symmetric, right? And so therefore, if this is n, that should be the same as 0. If this is n minus 1, this should be 1. If this is n minus 2, that should be 2. Note that the value of r is always the same as n minus whatever that number is. Okay? And so n over n minus 3 is the same number as n over 3. And that should always be the case. If you were to do this, you would continue on. That would be 3, and this would be n minus 3. And again, those are the same numbers. We just continue on with the process. So no matter what n over n minus 3 is, it should be the same as n3. And now at this point, I should be able to find out what n is. Okay, because it says the coefficient of x to the third is 80. So I need to get the coefficient, which means the coefficient will just be n3. Now I'm going to need the 2 to the third here as well. And then the 1 isn't going to matter because it doesn't matter what power 1 is to. It's just going to be 1, and that's going to be my x to the third. So this needs to be 80. And so I go n over 3. 2 to the third power is 8. So that means n3 equals divide by 10. 10. Now at this point you'd have a hard time doing this if you weren't able to use the factorial problem. And so we're going to rewrite this as n factorial over 3 factorial times n minus 3 factorial. Now, this is where it comes in handy to be able to understand factorials, because we're going to need it right here. So I'm going to take the top and I'm going to rewrite it. So this is going to be n times n minus 1 times n minus 2, and it just keeps going. But instead of keep going, I'm going to stop at n minus 3 and just say, okay, times n minus 3 times n minus 4 times n minus 5 all the way, all over 3 times n minus 3. Note that I can cancel out the n minus 3's. And then I should have that 10 equals n times n minus 1 times n minus 2. So if I distribute, that will give me n squared minus 3n plus 2 all over 3 factorial, which is 3 times 2 times 1, which is 6. So then I have 6 times 10, so that'll be 60 equals n cubed minus 3n squared plus 2n. Now, if this is a calculator, obviously I can just plug it in at some point. I can just say, okay, well, at this point I've got numbers. I can just put it in and find out when it's equal to 0. For example, I could just subtract the 10 here, and then I could put it into my calculator. Probably the easiest thing to do would be at this point to subtract the 60, work it out to this point, and then have 0 equals n cubed minus 3n squared plus 2n minus 60. And now we're just going to plug that into the calculator. So I brought up my calculator. One way to do this, of course, would be to just go into the y equals and put in n cubed minus 3n squared plus 2n minus 60, and then find the zeros. I want to show you another way of doing this, just because I think there's another neat way of doing this. And to remind you that you can go into apps, and I'm going to go alpha p, because I want the polysymbol 2. Remember, you have this available to you. You can do polysymbol 2, and you can push. You can go in and you can do the polyroot finder, and we have a third order. We want real answers. Fractions are okay. Okay, so we'll just say next. And so I'm going to type in the coefficients. It was a 1 in front of the x to the cubed, a negative 3 in front of the a2, a 2 in front of the n, and then a negative 60 down at the end. And then I push solve. And it solves for me and tells me that the answer is 5. So n equals 5. There's probably a couple other answers, but they're not real, they're complex. And so therefore you have your answer, n equals 5. Now you probably could have done this by hand. You'd have to do some synthetic division, but we don't have to really do that in this class. And so I would expect that this question would be some type of calculator active. So yeah, that's an example of a difficult binomial expansion problem, one that would require you to use this factorial. I'm not quite sure how you would solve for this n over 3 unless you were able to do this. I guess the only other option would be to just be guessing. You just guess different n values until you got to one that worked. With it only being 5, I guess, yeah, it wouldn't be that bad this time. Now, just as a heads up, if you do that, if you're guessing and checking, because some of you did that on the mock, if you're guessing and checking, what you have to do is you have to show the values that are close to that. And so what you would need to do is you would need to work it out and say, well, when n equals 4, I get this answer. When n equals 5, I work it out, I get this answer. When n equals 6, I work it out, I get this answer. Therefore, my answer is n equals 5. Okay, you can't just write down the answer. Otherwise, they're only going to give you the no work points. If you do this, then that's actually a proper method of guess and check to prove that it can't be anything else around it. It can only be this specific answer. Okay, so there's your review of factorials and a difficult factorial problem. This would only come into play if it was like a question 7, but it's getting more and more common that they're using the binomial coefficient as a question 6 or 7, and so you should expect maybe a harder question with that. At least it has been in past years. So there you go. That's a use for when you would have to have this. All right, that's all for now.